So since we learned about how to train our neural networks, now let's also take a look into how neural networks can be easily trained by using some libraries. And for the first part, let's learn some basics of dynamic programming. So as we learned in the basics of training our neural networks from scratch, we saw that we need to calculate a lot of gradients, the gradients of loss with respect to all of the weights and all of the biases. And this is actually too many computations. So we need to think of way how to do this more efficiently. So when we're thinking about neural networks are actually composition of functions. We apply some activation functions continuously, again and again, and do some chain rule again and again. So we can think of using dynamic programming because we have some recursive steps inside this neural network training process. Let's talk more about what is this recursive steps and how can we do some recursive programming. Let's first talk about a very simple recursive algorithm. When we're calculating some solution, which depends on solutions to smaller instances of the same problem. For example, let's say that if we're calculating some factorial, for example, 6 factorial, factorial of 6. This is actually 6 times factorial of 5. Or you can also write this as 6 times 5 times, because 5 factorial is also 5 times factorial of 4. And this can be continued factorial of 1. So this is recursive algorithm. We're doing this factorial function for the same problem, but a smaller instance. So what we need to do here is we need to have some function to call itself, which is actually impossible in the real world, but in coding. But when we're doing some programming, this is something possible. So when we're doing dynamic programming, this dynamic programming is a general and a very powerful algorithm design technique. For example, let's think about the Fibonacci numbers. In the Fibonacci numbers, we start with f1 and f2 equals to 1, and then we calculate fn with arbitrary with the functions of fn minus 1 and fn minus 2. So for example, we can calculate f3 using f2 and f1, which were both 1, so this is 2. Then f4 equals to f3 plus f2, and this equals 2 plus 1 equals to 3. If we think of a very naive recursive algorithm that can do the computation of these Fibonacci numbers, we can set some function like this one. Fibonacci number of n, this equals to if n is smaller or equal to 2, f equals to 1, and else f equals to Fibonacci n minus 1. So we are calling this function again. Fibonacci n minus 2, we're calling this function again. And then return f. This is a correct way. It will work. However, as an engineer, we also need to think if this is a good way to solve this problem. Let's see how our Fibonacci numbers are calculated. So if we want to calculate fn, we need to calculate fn minus 1 and fn minus 2. And to calculate fn minus 1, we need to calculate fn minus 2 and fn minus 3. To calculate fn minus 2, we need to calculate fn minus 3 and fn minus 4. What you can see here is fn minus 3 are repeated. Fn minus 2 are also repeated. And therefore, this calculation is not efficient. We need to think a better way. One way to do this is to use a memorized recursive algorithm. So here, this is the key, memorized. So we're going to save some Fibonacci numbers. So when we're calculating this function Fibonacci n, if n is inside our memory, we're going to just simply call that memory. And for the other cases, we're going to calculate the Fibonacci numbers as usual. And if it's not, and if we have done this process, then we're also going to save this in the memory. So if we do this, for example, if we're calculating fn, then we need to calculate fn minus 1 and fn minus 2. So actually now this fn minus 2 will be repeated with this one here. However, when we're calculating this fn minus 2 will be inside our memory. So there's no need to calculate fn minus 2 again. Also, for fn minus 3, those are all the same. By doing this, we can make our Fibonacci algorithm much more efficient. So when we're talking about dynamic programming algorithm, we're talking about doing this memorization technique, remembering the solutions from other instances, and reuse these solutions to subproblems that can help to solve the problem efficiently. So dynamic programming, inside here we have recursion and memorization. And the good news is that we can use this dynamic programming when we're training our MLP or neural networks. Because we are calculating the gradients again and again, we need to use the same information again and again, which is repeated. And if we put these information of the gradients in some memory, we are going to be able to calculate or do the backpropagation step and update our weights and biases very effectively. And the other good news is that we have a lot of libraries outside, like TensorFlow, Keras, PyTorch, etc. And in these libraries for neural networks, they all have these dynamic programming already implemented, so we can do very efficient training. And in this lecture, we're going to use TensorFlow Keras for some demonstration. So firstly, I'll just introduce the basics of training neural networks with TensorFlow. So when we're training our neural networks, we learned that this is a simple optimization procedure. So we are trying to find the best weights and biases that can approximate such function as well as possible. So what we do is randomly initialize everything and do some iteration, calculate some feed-forward step, do some evaluation of the loss function, and then do the backpropagation and update until some criterion is satisfied. So during these steps, we already know that we need to calculate a lot of gradients in our neural networks. And to do this one, even though we know how to do this from scratch and how to solve all of the gradients by our hands analytically, we can do this very easily by using numerical solvers that many great researchers have developed in the past. And especially, I told you that we're going to use Keras in TensorFlow.